Hello friends and welcome to YouTube channel Freedom Tech. And friends, we successfully detect objects with the help of yolov5 on our Raspberry OS Bullseye 64-bit version. So in today's session we are going to detect custom objects with the help of yolov5 on Raspberry OS Bullseye 64-bit version. Okay, so but before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much. And let's get started. So friends, if you don't know how to install yolov5 on Raspberry OS Bullseye 64-bit version, I will mention video link, watch video and install yolov5 on Raspberry OS Bullseye. Okay, so for today's session, for custom object detection, I have created here a repository. Okay, rpy yolov5. I will mention link of the repository inside the description box. You need to simply copy and paste the link inside the browser. That's it. Then go to the code and we are going to copy the link. Okay, like this way, copy the link and open terminal, and we are going to simply clone our repository. Okay, so run the command sudo git clone and paste the link of our repository and just hit enter. It will clone our repository. That's it. Now we need to change the owner. Okay, so run the command sudo chown space hyphen capital R. Okay, like this way, hyphen capital R, sudo space chown space hyphen capital R, pi is the user, then colon, pi is the group, and our repository name, which is the rpy yolov5. That's it. So we successfully changed the owner for our repository. Now we need to simply open our repository. So I am going to open file manager and rpy yolov5. This is what our repository. Okay, and inside that I have create the image.py. Then this is what our txt file, and this is what the Google Colab file for training purpose. Okay, so first we need to install some packages. Basically we are going to install label img on our Raspberry OS Bullseye for image training purpose. Okay, so this is what the text file. Simply right click text editor and it will open the file inside our text editor. That's it. So this is what the first package. Okay, so just copy the first package, open terminal, and let me clear screen and just paste the command which we copy it from our text file. Just hit enter. It will install pyqt5 on our Raspberry OS Bullseye, which I have already installed. That's it. Then our main software, which is label img. So again, just copy the command from our text file, open terminal and just paste and hit enter. It will install label img on our Raspberry OS Bullseye 64-bit version. I have already installed. Okay, so that's why it says, as you can see, the requirement is already satisfied. Okay, so this is how you need to install label img on Bullseye. So now we have our software. Now we need the images, the object images. Okay, for that I have created a Python file image.py. This is the Python script for capturing our object images with the help of our USB web camera. So I have connected the USB camera with our Raspberry Pi 4. Okay, so simply what we are going to do, we are going to open our Tony Python ID and we are going to open our img.py, open, then rpy yolov5. This is what our folder, and img.py. Click on OK. Okay, that's it. And if I make full screen, so this is what our script. Okay, it will basically capture 70 images. Okay, for each object. Okay, so max frames is basically 70. Okay, so it will basically capture 70 images of each object. So we are going to train here basically two objects. Okay, the first one is our Arduino board and another one is basically our Raspberry Pi Pico. You can train more images. Okay, so for today's session we are going to only train the two images, our two objects, which is the Arduino board and Raspberry Pi Pico board. That's it. So then where we are going to save our all images? So we are going to save our all images inside /home/pi images folder. Okay, cu2.im, right? This is what the path where we are going to save our images. Okay, so we need to create the folder inside /home/pi images folder. Okay, so right click, new folder, and images is the name of our folder. Simple. So images, and right now it's empty because we are going to basically capture our images. Okay, still there is no data. Okay, simple. And these images is basically our object name. Means here we are going to start with Arduino board. So Arduino is our first object name, so we need to mention that object name, and it will capture first object 70 images. Means it will capture Arduino board 70 images, and it will save all images inside /home/pi images folder. Okay, so let's just save the code, and we are going to simply run our code. Okay, then we are going to simply show our Arduino board to our USB camera. We need to slowly move our Arduino board in front of our USB web camera, then it will capture a different angle Arduino board images with the help of our code, and it will save all Arduino board images inside /home/pi images folder. Okay, so let's just start our code. Okay, so friends, we have successfully captured our Arduino Uno board images. So simply if I open file manager and images, as you can see, this is what our 70 images for our Arduino board. So if I go here, image viewer, as you can see, 70 images. We have here 70 images. That's it. So same way we are going to capture our Pico board image, RPi Pico board. Okay, so now here we need to change the name of our object. So now RPi Pico. Okay, now it will capture Raspberry Pi Pico board 70 images inside /home/pi images folder. Okay, so save the code and run the code. Okay, we have successfully captured our RPi Pico board images. So if I again open file manager and images folder, this is what our Arduino images, and as you can see, RPi Pico. So if I go here, image viewer, this is what our Raspberry Pi Pico. Okay, this is Arduino, this is what our Raspberry Pi Pico, as you can see. So we have successfully captured our object images. Now we need to simply use our label EMG software, and we are going to draw the rectangle on our object. So open terminal and run the command without sudo. Okay, lab, and just press tab button. It will auto complete our command. Okay, lab, press tab, and it will auto complete our command. Then just hit enter. It will open our label EMG software like this way. Click on open dir, select the dir where we have our images. So we have our images inside /home/pi images folder. Simply click choose, then change save dir, and the save dir is also same, /home/pi images. Click on choose. That's it. So now here we need to select YOLO. Okay, as you can see, the YOLO, and then we are going to simply create a rectangle box. So click on rectangle box, and then we are going to draw the rectangle box on our object, and here we need to mention our object name, which is Arduino. Okay, that's it. Click on OK, click on save, click on next image, again click on create rectangle box, and just create the rectangle box, and name is also same, Arduino. Just click on OK. So let me draw the rectangle on our all Arduino images. Okay, so friends, we have successfully trained our Arduino images. Now we have our Pico images, Raspberry Pi Pico board images. Okay, so again create rectangle, and we are going to simply create rectangle on our object, which is our Raspberry Pi Pico board. Okay, so rpi okay hyphen Pico. Okay, let's say rpi Pico. Okay, rpi hyphen Pico, this is what our name. Save it. Next, create rectangle box. We are going to create the rectangle and rpi hyphen Pico. Okay, same way again, save. Next image, create rectangle box, then draw the rectangle, click on OK. So now I am going to simply draw rectangle on our rpi Pico board. Okay, so friends, we have successfully drawn a rectangle on our object, which is Arduino and Pico. Okay, now we have done. Now simply we are going to close our label EMG software. So what is next? We need to open file manager, and here we are going to create again new folder, and the data is our folder name. Okay, mention same name friends, so data. Okay, and let's just open our data folder, and here we are going to create two folder, images, and another folder name is labels. So let's just create two folder inside /home/pi data. So again, new folder, images, okay, and then another one is labels. So we create a two folder inside /home/pi data. Okay, images and labels. Now inside images, again we need to create a two new folder. First one is training and second one is validation. Okay, so let's just create new folder, training, then second one is validation. That's it. Training and validation, same folder which we want to create inside our labels folder. Okay, same folder. So again, new folder, training, then second one is labels, sorry, not labels, validation. Okay, validation. Okay, so training and validation inside labels, and same folder which we create inside images folder. Okay, so now what we are going to do, we need to simply copy and paste our data inside our images training validation folder and labels training validation folder. So let's just press Ctrl A, it will copy all the data. Right click, copy, and back, data folder, images training, paste over here, all data, back, validation, paste the data, then back, then labels training, paste, then labels validation, paste. That's it. We have successfully put our data inside data, images, training, okay, then images, validation, data, then labels, training data, okay, same data, and labels, validation data. That's it. Now what we are going to do, we need to create a zip folder. So our command, I mentioned the command inside our text file. So our repository is basically rpi yolov5. This is what our text file, and this is the command for zipping our folder. Just copy it from here, open terminal, and just paste the command and hit enter. As you can see, it's creating our data as a zip folder. Okay, then we need to save our folder on our Google Drive. Means we need to upload our data.zip folder on our Google Drive. Okay, so simply open your Google Drive. As you can see, I have opened my Google Drive. Right click, okay, file upload, and then go to the Pi, and we need to search for our data.zip. As you can see, data.zip, click on open, and it will now uploading our data.zip. Means it will upload our data zip folder on our Google Drive. Simple. So meanwhile, what we are going to do, we are going to upload our colab file inside our Google Colab. Okay. So friends, as you can see, I have opened Google Colab. Here we are going to click on upload, choose file, and then we are going to simply open our yolov5 repository which we clone. Okay, and inside that I have shared our colab file. So just click on open. As you can see, this is what our file, ipynb extension yolov5 custom obj. Select it, open. Now it's uploading our file inside our Google Colab. Okay. So friends, we have successfully uploaded a file. Now go to the runtime, click on change runtime type, and here we are going to select GPU, click on save, and then click on connect. Okay, now it's connecting. So friends, we have successfully connected our file. Now simply we are going to run our first code. So just click on here. Now it will run our first code. It will create yolov5 train folder, and inside that it will create yolov5 folder. Okay, so we have successfully run our first code. So if I click here on the folder, okay, and as you can see, yolov5 train folder, and inside that we have yolov5 folder, and inside yolov5 we have all the files and folders. Okay, so second code, so just scroll down. So second code is for basically mounting our Google Drive data. Okay, so let's just run our code. Second code, connect to Google Drive. We need to give the permission, so connect to Google Drive. Now select your account, select it. Then just scroll down, click on allow. Now as you can see, it started our code. It will mount our Google Drive, okay, on my drive folder, and as you can see, it's mounted our drive, and we have our data.zip folder. Simple. So simply click on third code and it will unzip our data.zip. Okay, so we have successfully unzipped. Now if I go here, I need to click on yolov5 train, and then as you can see, we have our data folder. Inside that we have images, then labels folder, and training and validation, and inside training and validation we have all our data. That's it. So now what we are going to do, we need to simply go here, yolov5 folder, open yolov5, just select it, okay, yolov5, and then scroll down, and we need to make some changes inside dataset YAML. So dataset YAML file is basically inside our yolov5 folder. Okay, so as you can see, dataset YAML, click on double and it will open code like this way. Okay, so let me make like this way. So this is what our by default code, and here it is. As you can see, number of classes. So right now we are only training 2 classes. Suppose if you have 10 classes, you need to mention 10 because you are going to train 10 classes. So right now I am going to train here 2 classes, so I am going to mention only 2. Then here you need to mention your classes name. So we have already there. So next one is our second one is basically our arpy pico. This is what our second class. If you have more than 2 classes, so you need to mention their list as names. Okay, so I have here only 2 classes, so I have mentioned Arduino, arpy pico, and number of classes is also 2. So simply just click here like this way and press Ctrl S. That's it. It will save our code. That's it. We are ready, and now we are going to simply run our last code, which is this one. It will create our model. Okay, it will create our custom model. So let's just click on here. As you can see, it started the process. As you can see, it's basically scan all the data. Now as you can see, the process is started. Okay, 0 by 99. Okay, so it will take some time. Meanwhile I will pause video. Okay, So friends, as you can see, it's completed process and result save inside run train exp folder. Okay, so we need to go here again. Let's just click on here. Okay, double click, and then yolov5 train. This is our main folder, yolov5 train. Okay, click on here, yolov5 train, then go to the yolov5 folder. Then we need to go runs. As you can see, runs train and exp. So click on the runs folder, train folder, exp folder, and inside that we have weights folders. So just click on weights, and then this is what our model best.pt. So we need to download the model. Okay, so simply click on here and click on download. Okay, so now as you can see, it's downloading our model. As you can see, it's download our model. Okay, so let's just minimize the browser, open file manager and downloads, and as you can see, best.pt. this is what our model, our custom model. So just copy the model because we need to move our model inside our yolov5 folder. Okay, so we need to go here, home, and then we need to basically go file system root. Okay, file system root, and then usr, then local, then we need to go lib python 3.9 disk packages, and here we are going to search for yolov5. So just scroll down, and yolov5, as you can see, yolov5, and here we need to save our own custom model. This is what by default model for yolov5. As you can see, yolov5 s.pt. this is the by default model, and same here we need to paste our custom model, which is best.pt. Now what we want to do, we want to make some changes inside the detect.py. We need to basically mention our own custom model path. So this is what our custom model path /usr/local lib python 3.9 disk packages yolov5. Here we save our model, so we need to mention our model path inside the detect.py. So simply open Tony Python IDE, and this is what our old img.py file. So just close all these things, go to the file, click on open, and then go to the other locations, computer, search for usr, then local, then lib, then python 3.9 disk packages, and here we are going to search for yolov5 folder, and then our detect.py. Click on OK. That's it, it will open our detect.py. Okay, just scroll down, and here it is. As you can see, this is what by default path. Okay, this is what by default path for yolov5 s.pt. As I mentioned, this is the by default model for object detection, yolov5 pt. Okay, as you can see, yolov5 spt. So here we need to mention our own model. So again we need to create same variable, which is weights. As you can see, I have created the weights variable is equal to, this is what our path for our custom model. As you can see, as I mentioned, this is the path /usr local lib python 3.9 disk packages yolov5. Just copy it and just paste with single quote. As you can see, /usr local lib python 3.9 disk packages yolov5, and this is what our model name, best.pt. So we are going to use our own custom model, so simply we are going to comment the by default model. So let's just comment it, shift and hash. That's it. Save the code. Now we are ready, and we are going to run our command with the help of our terminal. Okay, so here what I am going to do, I am going to run the command. So command is like this way: sudo space yolov5 detect, and because we are going to use our USB camera, so we are going to mention source. So detect -- source source and our camera index number. So I have only one USB camera, so I am going to mention 0 as our index camera. Now what I am going to do, I am going to start my mobile camera, and I am going to show you a live object detection with the help of our own custom model. Okay, so I am going to start code, and then I am going to record all these things with the help of my mobile camera. Okay friends, and as you can see, it's detected our Arduino board. Okay, as you can see, As you can see friends, it's detecting Arduino board. Okay. Now we are going to show the Pico, our Raspberry Pi Pico board, and as you can see, it's detected our Pico board also. Okay. This is what our Arduino board. And this is what our Pico. Okay, so we have successfully detect our custom objects. Now simply click on terminal, press Ctrl C, and it will close our frame. Okay, so this is our friends, you can create our own custom model with the help of Google Colab, and you can simply train the object ImageX with the help of Label EMG software on Raspberry OS Bullseye 64-bit version. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.